All right, so a big shout out to Arnie. Whoops. Yeah, definitely not. Yeah. All right, so look, we just plug in for the derivative kc e to the kt on that side.
We're still in class over here. I saw that.
And over here we have, for y, we have a plus c e to the kt minus a. Hey, that's great. What happens to the a's? And then I multiply through and I get a check mark and a smiley face.
Can the answer to these questions ever be no, they don't work?
All right, well, so like number 2 is it a solution? And so I suppose you could end up saying no, it's not a solution, but I was saying it like, I don't know if it's this class or other class. I mean, there are an infinite number of wrong answers, and so it's sort of not as fun to pick a wrong answer. It's more interesting to say, oh, this is a solution. But I suppose somewhere along the way, you could run into one that the answer is no. Or, look, if the directions are show that it's a solution, it's going to work, right? If the question is it a solution? Maybe the answer is no. Who knows? All right, so let's see. Show that P equals P naught e to the t is a solution. 4. Oh, this is Julia's question. When is a derivative equal to the function? Right? And we're going to expand it a little bit. Not only when it's e to the t, but when it's some constant e to the t. It also works. But yeah, this is the insight that Julia had yesterday. So again, I do a little bit of side work over here. I know that's the function. And then the derivative of p naught e to the t. All right. And then it's just a matter of plugging in. There's what p is. So I'm going to put that in over there. And then here's what the derivative is. So I'm going to put that in over there. And guess what? P naught e to the t is equal to P naught e to the t. That gets a check mark and a smiley face.
We don't put a check mark in the smiley face.
No. Actually, when we were doing trig identities in pre-calc, I had students who didn't get the right identity at all, but put the check mark and smiley face to try to throw me off. Like, oh yeah, I got the right answer. No, you didn't. All right. What's next? 4. Is it 6? Okay. All right. So this one's interesting. We want to find the values for y so that y equals x squared plus k is a solution to 2y minus xy prime equals 10. So we're actually trying to solve for k. Same deal. Over here, we do a little bit of work, and we know that the derivative is going to be... Nope, other way. 2x. It is a constant. All right, so this is actually fairly typical. Second semester, we've been doing so much with integrating that you have to remember the difference between derivatives and integrating. All right, so there's what y is. I'm going to plug in there. Here's what y prime is. I'm going to plug in there. And we're going to try to find out what k is. So I get 2 times x squared plus k minus x times 2x equals 10. All right, what do we have? Algebra lovers, right? I told you, today's your day. So 2k minus... Yes, we're a calculus cult. That's great. Yeah, because the 2x squareds go, which is nice. K equals 5. And we don't need it, but just if you want to. I mean, it's not really like... No. We could actually just put the smiley face. The check mark doesn't really make too much sense. What's next, Morgan?
8.
All right. For what values of k? Same idea. We want to find out e to the kx is going to satisfy dy dx equals 10 minus 2y. All right. So same exact thing. I know what y is. And the derivative? 3k e to the kx, so it's 3 e to the kx, and there's the times k. The chain is right there. Okay? I'm sorry, that's a plus there. Alright, so the derivative, 3k e to the kx, equals 10 minus 5 plus 3 e to the kx. Oh, holy cow, definitely. Alright.
Holy cow, Arnie.
Minus 10.
Why is Arnie not here today?
I have no idea. I don't know. The 10s go, which is nice. And I think I get negative 6 e to the kx. So the e to the kx's, right, they go, so I get 3k is equal to negative 6. I guess k is equal to negative 2. Yeah, I felt like people were hassling me out the check mark because it didn't make sense. So, what is next? That's it?
No, 9.
That's sweet, isn't it?
Yeah.
Now, wait, just so you know, you still have to do 1 and 2. 1 is like a story problem, like match a graph with a story, which I always loved those. Didn't you like those in pre-calc? Like, here's the story, match it with a graph? No, Drew said no.
It's going to be after the rest of my problems.
I like that.
Just so you know.
It's going to be out of order. You're going to lose points.
Are you okay with that?
No, whatever you do, put 1 and 2, like, if you have to put a whole separate sheet on top of that, it's got to go in order, though. Because if I'm checking homework, it'll drive me crazy. Yeah, thank you.
And you're really going to be frustrated with my
No, I'm totally not joking. I mean, come on, you know me. I'm like crazy like that.
And you're really
I'll just squeeze it in really small.
Oh, yeah, that won't drive me crazy. But come on, you write so big and sloppy anyhow. It's like those first 2 problems are going to take up like a whole page.
Well, I can fit them in there, I think. Like 1, 2.
So what is your argument problems you check?
Probably.
Yeah, pretty much. Like 1 and 2 is going to be like, did you do your homework or not?
What number is there?
So you know that like one of you is not going to go home and do them. And you're going to be like, but I have all my homework. And we'll be like, no, we did that in class. All right, so this one's interesting because... You okay? So this is called a second-order differential equation.
So are we proving that that's the answer?
Yeah, sorry, I didn't... Is a solution to... No, that's my fault. So it's a second-order differential equation because it has a second derivative in it. So I know that sine of 2t, so I need to work through the first derivative.
Cosine of 2t times 2.
All right, 2 cosine of 2t. Derivative of a sine is cosine. And then you have to chain on the derivative of the inner function here. So that's where the 2 comes from. And so the second derivative... Sine or cosine? Sine. Okay, so now I just plug in for second derivative. That's going to be negative 4 sine of 2t plus 4 times plug in for y sine of 2t equals 0. Hey, yeah, it does. And just so in case I didn't want to, that came from here, right? And then y came from there. So it's really just about plugging in and showing. And like I said, in 3 days, or by the time we get to Thursday and Monday, you're not going to need to prove that answers are solutions. You're going to be able to find solutions, right? So yeah, you're going to be able. I'm going to be able to give you this equation. You're going to be able to say, oh, the answer to that's going to be y equals sine 2t. And it's a matter of learning a strategy and then applying that strategy. And that's probably like the last thing I have to teach you all year is that strategy. And then you're just going to use it in some word problems. Murder, drugs, all the fun applications of differential equations.